Dawn dish soap is an amazing product. It's extremely good. It works 10 times better than its products like OxyClean. It is really good at removing stains and grime, but it's still comfortable and smooth enough to work
What are you
on young
guys doing? You're just showing and you're just telling. It's not show or tell, it's show and tell. Next up is Mr. Ashish Jain, who will introduce us to people who can do just that, show and tell.
Thanks, Tanya. So, this is Ashish. It stands for Show and Tell Finale. And let me introduce Vipin Jain. He is Senior Fellow Engineer at AMD. He is also the co-founder and CTO of Presendo. Vipin has been leading cutting-edge networking and searching product for Presendo and AMD. Please join me welcoming Vipin Jain.
Thank you, guys. Thank you. My name is Vipin Jain, and I'm here to see technology in action. That's what I really love. Being a technologist and having worked in multiple successful startups, I can say that the most exciting thing for me is to not just see technology in action, but technology in action by young people. And that's really amazing. I want you all to give a round of applause for all our young talent here, which is going to be the entrepreneurs of tomorrow and the talent of tomorrow. Thank you. Okay, so at this point, I would like to introduce my fellow judges. We all represent the technology industry I'm from AMD, but we have other judges from Google, Amazon, and even one person starting his own company, and of course, Instacart as well. So please, I would like to invite Avinash, Dev, Mohit, and Avnish, please, on the stage. Thank you. Would you be kind enough to just give 2-line, 3-line introduction about yourself?
Hi, my name is Avinash Gupta. I've been in the technology industry for far longer than I'm willing to admit. Been 25 years in counting. Currently, I work at Amazon. Very excited to be here to meet the young minds.
Hi, I'm Tibbs. Right now, I'm at Google. Prior to joining Google, it's a couple of months back. I joined Google. Prior to that, I was at LinkedIn. I've been in the tech industry for 20 plus years. I'm super excited to be here.
Ashwani Verma. I have been in this area for almost the last 17 years. I have been worked on different startups. So recently, I have been in Simplicity as chief architect. Last year, I have started my own company. I work for healthcare company. Thank you.
Hey guys, my name is Mohit Gupta. Currently leading ads at Instacart. Prior life, worked at the large companies, Amazon, Google. For the last 10 years, I've been an entrepreneur. The reason I'm here is I get really excited when I see all these young kids. I'm a proud dad of 2 boys. These young kids taking an idea from a very inception stage to really solving customer needs. Looking forward to seeing a lot of the ideas.
Thank you, Mohit. So at this point, I would like to invite the age group of 7 and 8 to come onto the stage and start talking about their presentation. The format is really 2 minutes of video will be played. You all can also see what exactly they built, and we are going to judge them on their innovation, their technical strength, their execution, which is how good their prototype is, and ultimately their presentation as well. Age groups 7 to 8, please come on the stage.
All right, just one quick call out. All these kids also have working prototypes. They all are in the Aspen room. So if you guys want to go there after this, there are hundreds of kids doing their showcase. It's very difficult to bring everything and set it up in short time. So that's why we are doing the videos. But yeah, Mihir, can you take it forward from here?
Yes, we can have the first team readied up, and let's go ahead. So this is Prisha's Mighty Sansi.
I shall make people sick all over the world. And I shall Well, that was this germ guy trying to make people sick again. But thanks to the mighty Sansi, he's gone for now. So in the last video, I talked about the components I will be using for my project. But in this video, I'm going to show you the real working prototype, which means the real thing working in the real world. I'm also going to show you how my project works. So this is how my sensor looks like. As you can see, we have an ultrasonic sensor here, a breadboard here, we have an Arduino Nano here, and over here we have a server board. We also have wires here. So now I'm going to show you how it works. Into my computer. And now, let's see. I got some sanitizer. Now, may the germs be gone.
Hi. So my question is that, what motivated you to come up with this idea?
Well, when I go to stores or libraries, there are lots of automatic hand sanitizer dispensers. Well, they usually release the hand sanitizer so you can get some hand sanitizer. Well, sometimes when I put my hand under the dispenser, it doesn't really work. So that was what let me came up with the idea. So I thought I could instead pull down the tap instead of releasing the hand sanitizer.
Awesome.
I have a question for you. How long did it take for you to build this thing?
I'm not so sure. I think maybe 3 to 7 days. I don't remember.
Okay, thank you. What are the primary components that you think you had to use here? Can you tell me the top 3 components that you use?
The top 3 are the Arduino Nano, the servo motor, and the ultrasonic sensor.
Ananya, question for you. Did you test it to make sure it doesn't give false alarm? Did it ever dispose the hand sanitizer when it
I kept testing it. Sometimes it didn't work. Sometimes it does. I kept testing it until it was perfect.
1 minute left.
What was how big was the code for this? In how many lines of code did you have to write to make this work?
In Arduino IDE or in block code.
Yeah.
I think about 40 lines.
Okay, last question for you. Do you want to sell this product to anyone?
Maybe in the future, depending on how it works, or depending on COVID, if it comes back and it happens even more, I could.
Okay. What the price be?
I think about $20 to $50. I
Okay,
don't know.
thank you. And Arduino board costs how much?
What did you just say?
How much does an Arduino board cost?
I'm not so sure.
Okay, should be less than. Okay, thanks.
And that is time.
Mihir, let's bring down the next team video.
Absolutely. So the next team we have is Park Easy.
My name is Green Agarwal, and today I'm going to be presenting Park Easy, a smart parking lot. Have you ever been to a shopping mall? Parking spaces are so difficult to find there. Park Easy is the solution. It displays all the open spots of parking spots. two drivers saving their time. Let's see how this works. So there are 3 parking spots and 1 LDR in each parking spot. Now a car is coming and parking at the spot number 1. There's a microcontroller inside the box reading that the spot 1 LDR is not receiving much light. So it will display 2 and 3 on the LCD display because 2 and 3 are empty. Now another car comes and parks in spot 3. Microcontroller is reading that, and then it will display 2 on the LCD for open spot. Now all cars are parked. The microcontroller will read that, and then it will show lot full because the lot is full on the LCD. Now this car goes away, and the microcontroller will read that spot 1 sensor is receiving light, so it will display number 1 as open spot because 1 is empty. Now this is how people can easily park with Park Easy, the smart parking lot. Thank you.
Sorry, I didn't catch your name. Say your name again. Say your name again.
My name is Viren Agarwal.
So Viren, at this young age, when most of the kids are busy playing with the car, you came up with this idea. What was the motivation behind figuring out why do you need parking? Why do you need this? Who motivated you?
Because I have a lot of problems. My parents have a lot of problems finding parking spots and big parking lots. So that's why I came up with this idea.
Thank you.
I'll ask you another question. If you can look at me. So my question to you is, when you detect that there is a car parked or not, how far the display needs to be? Like, does it need to be nearby the parking, or can it be somewhere when you're entering the garage itself, like that can guide me to the parking lot?
It has to be somewhere. The LCD has to be somewhere where the drivers can see.
Oh, sure. But does it have to be close to the parking area, or can it be far away from the parking area where the cars are parked?
It can be anywhere.
Can be anywhere. Okay, thank you.
Viren, congratulations on a very cool project. Hello, here, hi. Viren, can I have your attention, please? Hi. What did you find was the most challenging part of your project?
1 minute left.
Challenging, but figuring out how will it detect the cars.
Got it. Thank you.
Viren, what are the technical components have you used in this? Just the one motion sensor, or do you have any other stuff?
And I used more components, so I used wires and breadboard inside the box, and that's all which is left.
Okay.
I have a slight variation of the same question. Instead of saying, tell me like I'm a 5-year-old, you're not far away. Tell me like I'm a 40-year-old. How does this thing work? What happens when a car comes in?
So the LDR will sense that there's not but the car. So microcontroller will read that and it'll display it on the LCD screen.
Thank you.
We have time for one more question. Okay, let me just quickly ask you a last question. Do you have to put any battery or something in the sensor, or is it always wired connected to the thing? In other words, what is going to be my problem maintaining this solution?
Yeah, so in life, you could just put a wire somewhere to a cable.
Okay, thank you. So it is wired connected all the way to the LCD, right? Not through wireless.
It's not wireless.
Oh, okay. So thank you.
All right. Thanks a lot. That was amazing. And then, all right. So before we start the next team, just a quick correction. I think one of the judge in the last girl, she was Presha, not Ananya. Just want to make sure so you do not mix up the names. All right. So Mayor, bring on the next team.
Hello, this is Squirrel. The ultrasonic sensor is directed directly to my peach tree. The cardboard covering will protect the device from any rain or other forms of weather. The ultrasonic sensor will detect a squirrel moving, and then, since it's wired to the Arduino, which is the brains of the project, the Arduino gets wired to the ELB. The buzzer in the ELB will ring if the ultrasonic sensor detects a squirrel in the middle of the peach tree and this device. Thank you.
Thank you for your project. It was exciting. I have a question for you. How do you know if you're detecting a squirrel or some other thing?
We don't know that yet, but if it's any animal, we should scare it away.
Thank you.
What are the unique arms that a squirrel possesses that you focused it on squirrels and not other animals?
Because squirrels are most easy to scare, and most of the squirrels only ate my peaches.
Thank you.
Same happened to me all the time.
Yeah, can you explain a little bit on technical stuff? What are the technical components have you used?
So if something's detected between like the ultrasonic sensor and the peach tree, it'll ring because it will know the distance because like you tell it before, and if it's before the distance of the device and the peach tree, then it will ring.
Okay.
So how can you make this even better?
I can make it from 3 or 4 sides so it can catch more of the squirrels.
Got it. What is the range of your sensor?
It's like 50 or 75% solid.
I see. Like how many meters can it
Oh.
detect the square?
At max you can do 13 feet.
Thank you.
What are all the components that you use to build this?
I use the Arduino Uno, the
1 minute left.
and ELB board because it has a buzzer and a 9-volt power adapter.
Thank you.
Yes, but then the device fried up. The device fried up.
I don't think the people can hear. Can you repeat the question, please? or maybe use the other microphone. Rishi, can you just check the microphones? There are some issues.
I was just asking, like, have you tried that in your backyard? Did you got any success trapping the squirrels?
Yes, we didn't trap them, we just scared them away.
How loud is the voice?
If it's in device range but far away, we make it a less sound. But we will make it if it's like close to the peach tree, then we will make it very loud.
Okay, so you can change it. Okay, thank you.
Time's up.
Let's bring the next team.
Hi, I'm Ananya. Today I'm going to explain about my project. The automatic plant watering system helps you to water your plant without any human intervention. The main component of the system are the soil moisture sensor, DC motor, pump, relay, and the embedded. You might have a question how this works. Let me explain. This works when the soil moisture detects if the soil is dry or wet. If the soil the soil is wet. You can see these when in the LCD display. When the soil is wet, you might get in the display the soil is wet and the moisture level, that how much if the soil is wet. You might get a green LED signal and the pump will stop pumping the water through the tube to the soil. The soil moisture sensor detects the soil is dry. You might get a display that the soil is dry and the value of the moisture, how much it's dry. LED signal, a red LED signal, and the buzzer will stop making a sound and this pump will stop pumping the water through the tube to the soil. Let me show you how it is done. Now the soil is dry. So the pump is passing the water through the pump. You might have another question. What if the motor stopped working? When you hear the buzzer sound for a longer time, the system is indicating you that there is some kind of problem in the motor. So you can come and manually check what is the problem near the motor. This wraps up my presentation of the automatic plant watering system. Thank you.
Ananya, do you see this working mostly for your backyard plants or large farmers or like super large farms? Like what scale or like what size of number of plants do you think this solution will work for?
I'm not sure, but it should be in a medium size.
Medium size? Okay, thank you.
My question to you is, what is the range of moistureness in the soil your device can detect? Like, if I were to scale from like completely dry to totally watery, in between that range, what range your device can detect the moisture in the soil to start pumping the water? And the second question is, okay, I'll ask the second question later. Please answer the first.
When the level is less than 500, it means the soil is wet. If it's greater than 500, it means the soil is dry.
Okay, the 500 means what? What is the unit of 500?
The 500 is the minimum range.
Okay. So my second question was, would you pump the water based on the moisture that is detected? And if so, how do you control the disposition of water for the plant? Like how do you measure what amount of water to be given to the plant in your device?
The motor will start pumping when only this
1 minute left.
Soil is dry, so I'm not sure how much the water will come from the tube.
Do you control the duration for which the water is going to be given to the plant based on the moisture that you detected?
The motor is controlled by the relay.
Okay.
Can you explain the technical components involved in this a little bit more? What are the components you used?
So the components that I used was the Arduino Nano, wires, soil moisture sensor, a single channel relay, and a pump.
Got it. So have you thought about applying this in some other field other than watering the plant? Any other use cases? Have you thought about it?
Yeah, because when I went for a long vacation, I saw when I went back to my home after the long vacation, I saw that my plants end up drying. So I thought of making this a system.
Got it.
So first of all, thank you, Ananya, for making this. I think a lot of my plants in my garden are going to thank you because they're no longer time. If you could make one thing better in this project, what would that be?
That would be I would use a solar to recharge the rechargeable battery.
Time's up.
Got it. Thank you.
You're welcome.
All right. Thanks a lot. That was awesome. And we'll take it forward in the next category, 9 to 11. Meher, take it away.
My name is Ansh Nahara, and for the Show and Tell on Moon Battle Conference, I will be presenting 2 prototypes, one of them physical and one of them digital. The physical one is here, this piece of cardboard representing a solar panel, and it will move along the way that the sun rises and sets from east to west. So as you can see, when I plug it in, it starts going from east to west, and during the night it will go back to its original position, like that. The digital one is on Tinkercad using 2 servo motors and 4 photoresistors to represent one of the servo motors moving the solar panel along the x-axis and one of them moving them along the y-axis. So as you can see, if I change the value of one of the photoresistors, the servo motors have changed their position, and if I change the value again, so it starts off like this and it ends like this. There's an LCD screen to display the degrees turned by the servo motors. So this would allow the solar panel to track light on all axes. Thank you.
So my question to you is, this is a great project. My question to you is, you said it moves into both axes, X and Y. So does it move based on where the sun is, or it always is fixed for a given location, knowing where the east and west is? In other words, do I need to calibrate it for a location, or can I just use it where you detect where exactly sun is at a given time?
So are you talking about the digital one?
Yeah.
So for the digital one with the 4 LDRs, the way it works, it would take the average value of all those, like the average amount of the light being detected by each of those. And then there's like a certain system, I'm not remember how exactly this works, but depending on that average, and there are 4 averages, one of the top, one of the bottom, one of the left, one of the right. So depending on which average is greater than the other, the servo motors will turn on that.
Thank you.
I have 2-part question for you. First question, how much more solar energy are you able to produce using this versus static panels?
So using the dual axis tracker, we could produce about 45 to 50% more energy than the original 20% per individual solar panel. The 50% is assuming that we use the best type of solar panel, which is monocrystalline silicon panels.
Second question, given there is this much improvement by rotating, by changing the direction of the panels, what do you think could be the potential reason why you don't see it right now? Why are most of the solar panels are still static? What could be the reason behind that?
So it all comes down to cost. There are companies, like there's a division of Amazon and a company called Soltech who are doing this right now, but it's still extremely expensive, both for maintenance and for production on a really large scale.
Thank you.
So if you have an intermittent sunlight, let's say in the morning there is a sunny weather and all of a sudden cloud comes, then in the evening again sunny weather. So how does it work in that kind of a scenario? Have you tested that scenario? Like,
So what you're saying is how would it work in like
1 minute left.
clouds?
yeah, intermittent cloud and sunny.
So it would continue to work the same way, just find out where the clouds are covering the sun the least, or where the clouds the sun shines through the most. This does work best though if you have a single axis tracker, which the dual axis tracker, as I shown on Tinkercad, moves against both axes. Single axis tracker tests have shown it is generally better for areas that stay cloudy, but things can change.
Okay. So, Ansh, what motivated you to build this?
So a year ago, I was in a robotics competition called FLL with my team, and the topic we had to build around on was something related to energy conservation, and we decided to build something similar, but it wasn't the most cost efficient. So from there, after the competition, it got me thinking. To this day, what are like the best ways to make energy, like better ways of collecting
Time's up.
energy?
Thank you.
Again, if you have to improvise one thing on top of dual axis, which is the most versatile one, what would you recommend?
Say again?
If you have to improve one thing in your current dual axis, demonstration you did, what would you improve there?
What would I improve is the fact that the LDR sensors are open. It would be much better to have it in like a closed, secure space. This one removes the part of the maintenance cost and time required to maintenance, and two, weather like rain or thunderstorms won't be able to affect that part. Same can go for the servo motors.
Okay, I'll ask you a totally crazy question. What if bird poops on your sensor? How that's supposed to work at that point?
So there we go back again. The sensor will, in real life, probably want to be closed, possibly underground. We can have a small chamber. Might be harder to build, but it would be safer long term. If the bird, say, poops on the solar panel, there are companies that make solar wipers for very low cost and very low energy requirements.
Thank you.
So that was awesome. I think thanks a lot. And Mihir, let's bring the next candidate.
Hi, my name is Vivan, and this is the finished prototype of my RoboMic. And this RoboMic has two major components, the servo motor and the LCD screen. When I play it, you will see that the servo motor moves at a constant beat, and while the LCD screen shows the lyrics of the song. Ready for it? Let's go. If you ever find yourself stuck in the middle of the sea, I'll sail the world to find you. If you ever find yourself lost in the dark and you can't see, I'll be the light to guide you. We find out what we're made of when we are called to help our friends in need. Thank you, and I hope you enjoy this demonstration of how the mic works as much as I enjoyed building it.
You're a good singer. Do you like music?
Yes, I love to sing.
Okay, that's what motivated you to invent this?
Yes, so one day I was thinking about the talent show because the talent show is actually today and I'm singing for it. So I was thinking and I thought, why not do a mic?
Besides the mechanical movement, what else can you play with in the RoboMic? Besides the mechanical movement of the thing and LCD display.
So I'm thinking of maybe making it able to add, because it took me 2 to 3 hours just to, and so I was thinking in the future, maybe I could make it so that it could read the files. So drag the file, drop it in the mic, let it download, and then, yeah. And also to have a, right now it's using an Arduino Nano, but in the future, maybe it could have a different kind of system and which will make the servo motor movement more precise.
What kind of a use case you have in mind where you can use this RoboMic?
So let's say you're at a concert where you're singing and you forget the lyrics. Then you could basically just glance down at the LCD screen and read
1
the
minute
words
left.
and see the servo motor rotate to tell you how long to hold the word.
Thank you. We look forward to getting more LEDs and color also.
Okay.
All right, bring on the next one.
If you
There.
This was good. So my question to you is, does it only detect objects that are stationary or moving objects as well? Like, something that's a dad or something like that.
So it can also detect moving objects and but only if it's at a specific position, because sometimes maybe if the object moves faster than the car itself, it can't detect.
Two-part question. First part, what kind of sensors are you using to detect the objects?
So I'm using 2 IR sensors and 1 ultrasonic sensor.
What are the other sensors that you considered when you decided not to use them, and why?
There's nothing else I didn't really not consider to use.
Okay.
Did you study the competitiveness of your competition, which is Tesla? I'm sorry. What I mean is how today's cars detect these things. Did you study that for your prototype? How do various full self-driving cars detect objects around them?
Could you repeat that?
So my question is that if you see there are a lot of detection that happens in cars today. Did you study what kind of sensors and technology do those things use compared to your mini car? It's very good.
Not really, because sometimes other cars may not use IR sensors or the ultrasonic sensor.
Thank you.
So, what was the real use case that you thought through before developing this?
The real life application? So the real life applications are designing a smart room cleaner for your home so that it can clean the floor. And another one is a food or a package delivery robot.
Thank you.
So Akash, congratulations on designing this. What was the hardest part for you in this project?
The hardest part was probably building the circuit.
1 minute left.
So when you were testing this, did you run into situations that you did not anticipate? And if so, how did you go about resolving and fixing your project to handle it?
So sometimes the car got stuck while detecting an obstacle. So I had to change the code a little bit. And
okay, thank you.
Was there a toughest bug that you recall debugging when you were building this? Was the most tough thing you were losing your sleep over, or something that you spent most time on?
Could you repeat?
So let's say when you're writing code, there was a problem in the code. What was one problem you spent the most time on?
I'd say in the analog write commands, the car was only moving backwards. And when the right IR sensor detected something, or the left IR sensor, it normally just only went backwards and it never turned to the right or left.
All right, judges, are we good? All right, thanks a lot. So I think we'll move to the, congratulations, we'll move to the next segment. So we have seen the 7 to 8, and then we have seen 9 to 11. Now we'll move to 12 plus. Meher, please invite the first team.
So Tejas was the first one in the 12 plus category, and now we have the next one.
Hi, my name is Aline Lawrence, and I'll be presenting my project, It's the Ripe Time for Harvest, on April 21st at the Moon Battle Conference. Let's get started with a live demonstration. First, I'll upload my code, and then open the serial monitor. This will display my results along with the LCD. Let's get started testing with a green unripe tomato. We'll be taking measurements first, so the LDR values can be recorded. As you can see, the values are in the 600s. I take these measurements about 3 times. And now we'll be testing on the ripe red tomato. As you can see, the values from the LDR are much higher. And one last time. These are just for measurements. Now the code will be calibrated to find the mean of the values, which is 711. Now we'll be testing on them to see if they're ripe or not, and if the code can determine this. So let's get started with the green unripe fruit. As you can see, it was accurately determined that it was unripe. Let's do the red ripe fruit. Once again, accurate, ripe. And one last time with the green. So through these, I hope you can understand how this project works. Thank you so much. I hope you enjoy.
This is good. This is good. I think all farmers could use this to ensure they pick it at the right time. It has a lot of applicability. So my question is, I know you are using maybe color sensor and or moisture sensor. I don't know what exactly you are using to detect the ripeness, and will it work in all kinds of things, or is it a special thing for tomatoes and different others?
So the type of sensor I'm using is actually an LDR, a light-dependent resistor. So that is actually the only sensor I'm using. And so it's more complex than using a color sensor. It is detecting the reflected light from the there's yellow light directed at a yellow object, in this case, supposedly a banana. Then the banana is yellow, so it'll reflect back more light. But if you have a brown object over yellow light, it'll absorb that yellow. So, and it has been calibrated so that it should be able to work in most lighting conditions.
And on most fruits as well, or just select ones?
Specifically only for color changing fruits. So it has to change color when it ripens.
Got it. Thanks.
In the prototype you showed, like you are taking a couple of different tomatoes, a green and a red, and trying to figure out what should be the right level. Do you plan to use that like for each fruit, each vegetable, which does change the color? You figure it out, like what the value, or you plan to use some kind of a machine learning model that can tell automatically this is the threshold above which it's ripe, below which it is still not ripe.
So this is simply a small prototype of a small level like introduction to this idea of using technology to determine harvest and when you should harvest. So on a larger scale, it would be a whole lot better to use machine learning and AI, especially if you're going to scan through a whole farm or a whole field, or even just like a stall at the grocery market. It would be better to use AI because AI would be more specific. This model is not exactly always precise, but AI would be easier, especially
1 minute left.
Thank you.
So are you planning to make this as a product?
I hadn't really thought about that until now. I think it would be interesting, but I would have to like refine it a little bit more. So like work out the kinks a little. And obviously this in itself is not the most efficient model, but and like I've said, AI would be the next step in this product.
So building this prototype, what are the challenges that you faced?
So the main challenges for this prototype was the placement of the produce above the LDR and LED. Otherwise, outside lighting would affect the results. And so every time you'd have to make sure it was placed the right way. Otherwise, the results could be affected, like false negatives, false positive scenarios. That happened a lot. So I had to kind of work it out just right. Along with that, I needed to know what number for the calibration, what number it needed to be above for ripeness. and what number it needed to be below for an unready fruit.
Got it. Thank you.
So can the same device be used across multiple categories of fruits or vegetables, or does each device need to be calibrated for a specific fruit or vegetable?
So the calibration happens during the measurement of the code or measurement of the produce. So while we are one time to measure the produce, if you're handling it in one place in the same room, then the lighting should be about the same and you won't need to recalibrate. But throughout the devices, it might have to change.
Got it. So just to make sure I understand, in the same room, if you're using the device on an apple or a banana, the same prototype would work. You don't need two different prototypes of calibration.
I believe, yeah, the same prototype should work the same way, and the calibration number would remain constant.
Thank you.
Time's up.
Okay.
All right. Thanks a lot. Mehul, let's bring the next candidate. Thank you. It was amazing.
Hello everybody, this is my project for the show and tell competition, the Garden Bot. The Garden Bot is an Arduino controlled robot that is designed to keep your garden in tip-top shape. This robot has many functions that we will be going over later in this video. Hello everybody, this is the Garden Bot with its cover on. The Garden Bot comes with a cover so it isn't affected by any rain, and it also comes with a camera where you can detect for diseases and check if there's any security intruders coming inside your house. It also has an LED matrix to display messages, and it has obstacle avoidance. So I'll put this bucket in front of it and we'll see what happens. It's detecting the bucket. And it moves away. Hello everybody, this is how we will spray fertilizer out of our robot, or it can be pesticide. Either way, you can fill it. You can see that the solar panel is charging this robot, and so it is watering the plants, or it should be fertilizing the plants.
Hey Tejas, could you please explain exactly what this product does? What is this prototype about?
This prototype is about a robot which is designed to take care of your garden with a multitude of features that allow it to take care of the garden.
Like what?
Like you could say seeding, dispensing fertilizer along with pesticides. You could say tilling, and also cameras to watch the garden.
Got it.
So what is the size of your garden bot? How big is it?
It is around 6 inches by 6 inches. It's not very big, but in the future models I plan on making it bigger.
Got it. So for an average size backyard, let's say 2,000 square feet, how long do you think it would take to either fertilize or seed using the garden bot as it exists today?
It would take maybe, I don't know, 5 minutes, 6 minutes to go through the entire garden, but it might have to take multiple rounds.
What is the velocity? What's the speed at which your garden bot moves? The maximum speed?
It doesn't go very fast, so that every inch of the soil will get an equal amount of fertilizer and pesticide. Maybe it goes around like 0.2 miles per hour. very slow.
Okay, thank you.
So it looks like you have packed a lot of functionality into this tiny thing. What is the complexity of your code and logic? Can you give us a sense of like, how much code did you have to write to take care of all the conditions?
Well, I had to write about 200 lines of code for the entire project, but I split it up into different parts and then added it back together.
What programming did you use?
I used C++ with an Arduino Uno.
If you have to pick one of the things that your robot is very good at, technically and accuracy wise, what that feature would be?
What my robot is good at would probably be
1 minute left.
the efficiency and mostly if there was one feature I had to pick, it would be the fertilizing.
Okay, let me follow up one more question for you. So, in many cases, you have to do the pesticides not in the ground, like up in the air. So, what's your take on a robot which is on the ground to handle that? I suppose your robot cannot climb the trees.
Yes, but in the future, I'm planning on adding a drone-like interface, so we could make a detachable drone on that. That would be a future project for me, but on this robot.
Thank you.
All right, that was amazing. Thanks a lot. All right, Meher, can we bring the next candidate?
Yes.
Hello.
Yeah, hello. My question is, if you can describe a little bit about what was there on the display and what way it was integrated with the rest of things. In other words, describe a little bit more about your innovation and what was there on the display.
All right. So on the display, there was the time and the date. And I was using a LCD 320 by 480 display to display the time and the date. And it also included an RTC to keep track of leap and daylight saving time, and a buzzer for the alarm. And it was running on an Arduino Mega board.
Thank you. And the use for this would be to wake me up like a regular alarm, and
It'll also show your daily schedule. Like it will be displayed on the screen.
okay, thanks.
Yeah, does this work like a similar clock?
Yeah.
Okay. All right.
What makes you confused about this one? So I made it because I needed to balance multiple extracurriculars and homework. So I needed a schedule for that. And since I often looked at the time, I got the idea to combine them both. So whenever I looked at the time, I could tell what I'm supposed to do at that time.
How do you feed the schedule into this device? Is it synchronized with something, or
Well,
do
it
you
is
have to-
synchronized with the time. So whenever it's 10:30, there's a certain when it's 10:30, it'll display what you're supposed to do at 10:30.
like if it's that time.
Correct, but how does it know that what you're supposed to do at 10:30? Is it synchronized with my calendar? In
It's
Google?
synchronized with RTC, which runs on, like, I made it time, like, the Arduino Uno, Mega to run on the, well, time, like, every, like, you add like, one every time a second passes, and every time the seconds reach 60, set it to 0 and add into the minute.
Right.
Yeah.
No, I got the time part, but how does it know what it needs to be done? Is it taking that input from someplace, or are you telling that your schedule and feeding it into this device?
Yeah, I'm feeding it
Oh, you're
into
feeding
the
1 minute left.
Okay, great. Okay, let me ask a follow-up question then. If you were to make one of the improvements, what would that be?
Well, I'd make it customizable. Like if you want a certain background, like a color or an image, I'd make it so it could be displayed like on the background. Like you saw the black border at the edge, it could be changed.
Got it. Good. And do you see what are the technical challenges for the schedule to be synchronized with my calendar? I mean, I would love to carry this if I can synchronize with my Google Calendar or some other calendar.
I plan to do that in the future.
Okay. Awesome. Thank you.
You're welcome.
Does it have to be connected through wire, or you're planning to do it with the Wi-Fi?
Doesn't need
A
to be
Bluetooth
connected to be anything.
Uh-huh.
Like just a 9-volt battery or power source.
Got it.
Are you ready for the show and tell finalists to accept their prizes? We're going to invite Vipin to grant these prizes to all of our amazing contestants.
Okay, prize time. So there were 3 categories, 12 plus, 9 to 11, and 7 to 8. I'm going to start with announcing the results for 12 plus category first. The third prize in 12 plus category goes to schedule alarm clock. Congratulations.
I should probably,
job.
oh yeah, I'll be just fine.
Made it all the way. Big applause for him.
You don't waste your time.
Okay, there you go.
That alone, yeah.
Good job. Keep it up.
That's what you want.
Okay. 12 plus category. The second prize goes to Garden Board Pages.
If you feel like a
Congratulations. That's your prize. Thank you. Take care. Take a picture. And the winner of 12 plus category is Ripe Time for Harvest, Ellen. Prize number 1. Thank you to all these awesome kids. I am amazed at the work they've done. Thank you all.
That's what you want.
So we come to 9 to 11 category, and the decision making was certainly tougher in this one. Third prize goes to RoboMic, Vivan. However, I want to say one thing about this prize. Come on, Vivan, come on. We found this to be the most innovative. So, honorable mention for the most innovative out-of-box thinking. Vivan, keep it up. Thank you. Just stay there. I'm going to call other people as well. Second prize in 9 to 11 category goes to Sensormatic, Akash. Good job, Akash. Good job. Yeah. Please stand here. And of course, the winner is light detecting solar panel. Anj, can you please come on the stage? Come on here. So, good job. Congratulations to all 3 teams, first, second, and third prize in 9 to 11 categories. Thank you so much. Keep up the innovative bulb in your mind going. You know, this is not a RoboMic. I hope to carry RoboMic one day. Thank you for all your work. Please. Thank you.
If you feel like happiness is
Okay, so with this, I think the most, I would say, difficult decision we had to make was for 7 to 8 year category. And
I assume the audience can agree with us on that one. So the third prize in this category goes to Squirrel. Vian, please come on the stage. Third prize goes to Vian, Squirrel. Good job, Vian. Awesome work. Awesome. Okay. Second prize goes to Mighty Sensi, Prisha. Wow, this is too heavy. What about the first prize? I told you guys this was tough. We have 2 winners in this first prize. Parkeasy, Viren, and Automatic Plant Watering System Ananya. Please come on the stage. You are the winners of this one. Yeah, but I'm going to help you. Wow, look at these kids. Awesome. Big applause for these kids. Awesome, guys. So proud of all of you. And you guys gave us a tough among all 3 categories. One more applause for 7 to 8 year category. Good job, guys.